Welcome to Reproduction 7, Embryo Transfer. Superovulation and embryo transfer in cattle. First, we need the donor preparation. So we have an outstanding cow and she's going to be the donor of embryos. So FSH, and FSH again is follicle stimulating hormone. It's going to stimulate the ovary to produce additional mature follicle. So we're going to inject beginning on day 8 of the ester cycle and continue every 12 hours for a total of 6 injections. Prostaglandin is going to cause the CL to regress and to cause the cow to come into estrus 2 to 3 days after that prostaglandin injection. We're going to inseminate towards the end of estrus. We may give 2 inseminations 12 hours apart. 7 days after our insemination, we're going to collect the developing embryos. So the embryos at this time are floating around the uterus. So this kind of illustrates the tool that's used. So this is our cuff deflated. The instrument goes into the through the cervix. So we're through the cervix now. This balloon is inflated to block any liquid flow back through the cervix. So we've got this saline solution. It's going to go through the instrument and flow through the cervix, through the uterus, and then back out the instrument, and we're flushing the eggs, or flushing the developing embryos down into our flask down here, and hopefully we collect quite a few. The number of good embryos collected will range from 0 to 35. So it's many times hard to really predict how many embryos you're going to get. It's not unusual at all to have 0. The average is probably about 6 to 8 good embryos. So the embryos are examined underneath a microscope. Good embryos are put into recipients, or they can be frozen for later use. Okay, so now we want to get those embryos into recipients. So the ester cycle, the recipients are generally synchronized, so that the same stage as what the donor was if we're putting in fresh embryos. So we flush the donor at day 7 of the ester cycle. The recipients need to be at day 7 of the ester cycle. A pipette is used and the embryo is deposited right in the uterine horn on the same side as the CL of that recipient. A newer procedure is called in vitro fertilization, or IVF, and it's becoming relatively common. In this case, immature ova are aspired directly from the ovaries. It can be done every other week on an individual. It can be done on pregnant animals as long as the pregnancy is too far along so that the ovaries are way down into the body cavity. It can be done from ovaries taken from dead or dying cows. In fact, ovaries can be collected from the slaughterhouse. These immature oocytes are fertilized 1 day after collection in a dish using a small amount of semen. Embryos are then cultured for 7 days in the lab and then placed into recipients. One advantage of the IVF procedure is that from 1 dose of semen, we can have donors in our petri dishes in the lab, and from that 1 dose we can get 100 to maybe 200 viable embryos from just that one dose of semen. And if that semen is extremely rare or elite, I think you can see where this could be an advantage. Cloning is not nearly as common as embryo transfer, but a certain level of cloning is done on very elite animals. So first we need a empty egg. So we've got a donor here that's going to donate an egg, and we take the nucleus out, so we get a empty egg. And here we have the genetic donor, a very elite animal. And this is illustrating in cattle, but dogs have been cloned, and sheep have been cloned, pigs have been cloned. So we just collect a few cells, and we culture the cells. And then we take a cell and we put it in this egg. So we've got the identical genetic material from what the donor cow was. We culture the embryo. We put the embryo into a recipient, and about 280 days later, we'll get this calf born that's an exact genetic copy of the mother. Well, just backing up how important is embryo transfer. In dairy cattle, about 1% of the calves born in the United States were born as the result of embryo transfer in 2018. Greater than 95% of the bulls going into AI were born as a result of embryo transfer. Just another data point, about 10% of registered Angus calves were born as a result of embryo transfer. So if you look at the total number of bovines born in the United States, right now it's about 1%, and the amount of embryo transfer has been increasing at a slow rate each year. If we look at other species, embryo transfer can certainly be done. In sheep and goats, it's less than 1%, but it has been increasing among individuals that have the very elite show animals and show genetics in sheep and goats. Pigs, almost none, and one of the reasons being is that if you have a elite sow, she can have 20 offspring a year pretty much naturally, where with these other species you're only going to get 1 or 2 offspring per female per year naturally. Horses, it's increasing slightly in some of the breeds. Some of the breeds have breed restrictions, but definitely I think we're going to see an increase in embryo transfer of horses as we look into the future as well. Well, this slide shows the increase frequency of embryo transfer in dairy calves over the years. So you can see from year 2000 to 2007, it remained kind of constant, and it's been kind of increasing since that time. And even though it's probably just about 1% of dairy calves are born as a result of embryo transfer has greatly helped the genetic improvement that we've gotten per year. Because as far as the embryo transfer, it's the very elite animals that are being super ovulated, so we're getting additional good genetics from the very elite animals. So it's a low percent of the population, but embryo transfer can contribute to increasing the genetic progress that we make. Now we just have some examples of famous clones. So Man 2 produced hundreds of thousands of units of semen after his clone had died, and contributed greatly to genetic improvement. Here we have 3 Angus calves. They're all cloned of a genetically superior donor. Well, this is an interesting clone here. Research went into a beef slaughter plant and watched thousands of carcasses go by on the rail. Once they found the perfect carcass, heavy muscle, great meat quality, they grabbed a kidney off that carcass and got a clone from the genetics of that kidney. So the cow here is a clone of that perfect carcass, and with her calf standing by. Here we have several clones of a famous show pig, Miss Pauline. Here we have a champion from the World Dairy Expo and a younger version of herself. A red and white Holstein Apple was a champion at the World Dairy Expo, and several years later, one of her clones, Apple 3, was also a champion at the World Dairy Expo. Heat Wave was a real famous bull that sired many champions across the United States. He was cloned many times, and semen was sold from 15 of his clones. Well, that concludes the video here on embryo transfer and cloning. Have a good day.